Good morning, everybody. We are continuing today with lesson 4, and we are just going to do some more practice with the normal distribution. So you definitely are going to want to refer back to lesson 3 that we did on Thursday, but it's going to be very similar. We're going to talk a little bit more about percentiles today and just finding maybe not always the percent, maybe finding to the nearest whatever they're talking about. So very similar to what we've been doing, just maybe taking it one little step further. So in example 1, there are 440 students in this school. And they're all enrolled in U.S. history. On the April report card, the students' grades are approximately normally distributed, so we need to know that. The mean is 79, and the standard deviation is 7. Okay, so students who earn a grade less than or equal to 64.9 must attend summer school. Find to the nearest student. So we're not talking about a percent. We need to the nearest student. The number of students who must attend summer school. Okay, so if we have our mean, okay, right here, which is 79, and they're talking about our standard deviation is 7. So even if I start to subtract 7, your 64.9 is not going to be exactly 1 or 2 standard deviations below that mean. Let's just say your 64.9, which is what they're talking about, is here, right? We want to know to the nearest student how many students would attend summer school. Now, you're attending summer school if it's everything less than that 64.9. Okay, so if you remember, we're going to use that normal command on our calculator. We're going to type in our normal, and we're going to always start with the mean, 79, comma, the standard deviation, 7, and here we want to know everything less than 64.9. So I just want to remind you of something. There's pretty much 3 different situations that they could ask you about. Either below whatever they're talking about, where your probability is below a certain number. That's this situation where it's everything below 64.9. That's when you're going to just type this in, and you're going to, whatever probability you get, that's what you're using. If it was everything, let's just say above 64.9, that's when you do 1 minus what they're talking about, the probability. And if they say, the probability between these two numbers, you would have to find those two probabilities and then subtract them. So that was on Thursday's lesson. Okay, so if I go into my calculator and I do normal, and we're going to say our mean, comma, our standard deviation, and everything 64.9, we get this decimal, right? And I'm going to write it down. 0.02198 ... Now, usually I would say, okay, that's your answer, or we're going to turn it to a percent. But here, they didn't want you to do that. They wanted to know to the nearest student. So you're going to take that number and you're going to multiply it by your 440 students. So I'm going to take here my value, which is A, and I'm going to multiply it by 440 students, and that's the number you get. You get 9.6754, something like that, which to the nearest student, 10 students. Okay, so again, we're just taking it one little step further, taking your percentile, and I shouldn't say percentile, yeah, it is kind of your percentile, and or your probability, and multiplying it to find the number of students. Okay, so look at number 2. A juice drink manufacturers filling these boxes. Okay, so there is a normal distribution. The mean is 1,002 milliliters, and your standard deviation is 0.6. So any boxes that contain less than 1,000.8 milliliters are rejected. How many boxes? Okay, so again, how many boxes? Not what's the percent. how many boxes will be rejected in a production of 30,000 boxes. Okay, so again, your mean here is 1,002, and your standard deviation is 0.6. Okay, so if you were, so your 1,000.8 is going to be here. You want to know 1,000.8. You want to know about how many boxes are going to be rejected. So it's if they contain less than 1,000.8. So that's all this way. So that's that same situation. You're going to take your normal. You're going to find your probability if you have a mean of 1,002. Your standard deviation is 0.6, and you have 1,000.8. Okay, so let's pull this up. And I am going to do normal. 1,002, I missed the 0, comma 0.6, comma 1,000.8. Okay, so that's my percentage. No, I missed that decimal point here. 0.6. Okay, so you get a probability of, it's like 0.0227, 0.227, something like that. But again, you want to know what the number of boxes are going to be. So we're going to multiply that by your 30,000 boxes. So I am going to take my letter C, and I am going to go back and multiply it by 30,000. And I get something like 682.503 boxes, which is 683 boxes. Not so bad. So just be aware of exactly what they are looking for. Okay, so let's talk percentiles. So a percentile is just a measure used in stats indicated the value below. Okay, so that's really important. I feel like, you really need to understand what exactly a percentile is. It's the value below the given percentage of observations in a group of observation is falling. So in other words, if an observation is in the 20th percentile, it means that blank percentile of the data lies below it, 20% lies below it. Okay, so it's indicating the value below the given percentile. It would also mean that blank percent of the data lies above it. Well, if it's 20% below it, then it's obviously 80% that lies above it. So you see that, I feel like, a lot on your SAT report and PSAT report, what percentile you scored in. Understand, so like this next question, I feel like it are good questions, but like if you scored in the 75th percentile, you scored as well as 75%. 25% of the people scored above you. Okay, so obviously the higher the percentile, the better. The weights of newborn babies are normally distributed. Okay, so let's talk about this question. Your mean is 2,950, standard deviation of 340. So they want to know what's the percentile rank to the nearest percent that a baby weighs 3,000 grams. Okay, so now let's talk about this. You want the percentile rank. You're going to use the probability and the percent to get your percentile rank. So you could just literally say to yourself, okay, I'm going to use my normal, my mean, my standard deviation, and the weight of the baby, 3,000 grams. A baby that's weighing 3,000, that's going to give me technically my probability at or below the weight of 3,000 grams. So if I go here and I say, let me clear all these out, and I do normal, I do my 2,950, 340, and 3,000. I missed a 0. Okay, I get this probability, 0.5584, blah, 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 blah. So as a percent, what is that? That's technically 55.8%. So as a percentile rank, that's in the, to the nearest percent, they said, 56th percentile. Okay, and just thinking about this, like, just talk common sense. If a baby is weighing 3,000 pounds, was that greater or less than the mean? So here was your mean, 2,950. It means that this should be, this is above the mean, so should be greater than the 50th percentile. Right? Because your mean is right at your 50th percentile, right in the middle. Okay, so what is the percentile rank to the nearest percent of a baby that weighs 2,500? So just using that common sense that we just talked about, your 2,500 is going to wind up being, because it's underneath the mean, it should be less than your 50th percentile. Okay, so we're going to do, again, our normal, your mean, standard deviation, and now we're talking 2,500. So let's talk about that baby's weight. Okay, so we're going to do our normal. We're going to do 2,950, comma 340, 2,500. Why do I keep missing a 0? Good. Okay, so that's 0.0928. Again, approximately 9.3%. So that's going to be the 9th. Get rid of this. 9th percentile. I hate when it comes out so big. Okay. All right. Moving this along. Hopefully you guys are getting this. Okay, so let's talk about Mark. Mark received an SAT score report that says he scored in the 55th percentile. He tells his friends, at least I got more than half of the questions correct. Explain why Mark's statement is incorrect. So again, does the percentile rank mean how many he got correct? No. So just understand that percentile is not, it's not percent correct. I would say rather it's the percent, rather it is it's the percent that Mark did better than on the test. Okay? He had that percentile, that 55th percentile means that he scored as well or equal to 55% of the students that took the test. Not he got 55% correct. If SAT scores, okay, so if they're normally distributed, you have a mean of 1,083, standard deviation of 194. Did Mark score at least an 1,100 on his SAT? Okay, so did he score at least an 1100? All right, well, let's see. We could take our mean, 1083, our our standard deviation, 194, and take that 1100 and figure out his percentile rank. All right, so watch this. If I do that, I don't like it this big. If I do normal, and we take 1083, 194, and his 1100. Okay, look at that. 0.53491, which is what? Approximately the 53rd percentile. Okay, so is it possible, what they asked, did he score at least an 1100? Yes, because he did better than 1100. His percentile was greater. So I would say yes, Mark did better than 1100. His percentile rank was greater, right? What was his percentile rank? 55%. So this 1100 was only in the 53rd percentile, so he definitely did better than 1100. Let's talk about Mark's friend Sarah. She got an 1150 on her SAT. Did she do better or worse than Mark? Okay, so it's got to be pretty close. We're not sure exactly, so let's check it out. Let's see what her percentile rank was. If we do our normal, we do our 1083 as the mean, 194 standard deviation, and her score was an 1150. Okay, so let's see what this was. Let me clear out. We got our normal, 1083, 194, 1150. Okay, so she 0.6350, which is about the 63 and a half, 64th percentile. So guess what? She did better. Sarah did better. Her percentile is higher, I would say. Sarah did better. Her percentile rank is higher. Okay. Okay, let's take a look at 5. Okay, in 5 it says 2 versions of this standard test is given in April and in May. So the stats for the April version test show a mean of 480, standard deviation of 24. Okay, the stats for the May version saw a mean score of 510, standard deviation of 20. So assuming the scores are normally distributed, Joanne took the April version and scored a 525. All right, so we're just looking, I'm just going to say, okay, this is April, this is May, and we know in April, our mean was 480, and we had our standard deviation was what, 24? Okay, so we know in May, the mean was 510, and our standard deviation in mean was 20. Okay, so I'm not going to put them all like your 1 standard deviation, 2 standard deviation in, because in these questions you'll see like it's not exactly 1 standard deviation or 2 standard deviations above or below the mean. Your numbers are somewhere in between. So in this first one they're talking about April scored a 525. Okay, so obviously greater than the mean. She's about here. So they say, what's the probability to the nearest 10,000th, that a test paper selected at random from the April version scored as well as Joanne. Okay, so let's talk about as well as Joanne. If you're talking about figuring out how many people scored as well as Joanne, we're talking about all the people above or at 525, right? If you're talking about as well as Joanne, yeah, you're talking about all these people right here. Scored as well as Joanne. Because all those other people are below her. So we really now want not just the probability that you were at or below the 525. Now we're talking about above that 525. So this is a totally different situation. This is where on Thursday's lesson, instead of just normal 480, your mean, your standard deviation, your 524, you want to take that probability and subtract it from 1. In other words, 1 minus your normal, your 480, minus comma your 24 and your 525, because anytime you want your percentile or your probability above that number, you have to subtract it from 1. Go back to that Thursday's lesson. So you could put this all right into the calculator technically just like this. Save yourself that step. I could do 1 minus, and then I can go in and do my normal. I could say 480, 24, and 525. So that's going to give me my probability. I'm just going to make it a little smaller. It looks like, did it not give me the minus? Oh, here it is. Okay, so I have 0.03039, something like that. So now they want it to the nearest 10,000. So they're looking for 4 decimal places. 0.0304. Here's your number in the 10,000ths place. So that would be your answer. They didn't want it as a probability. They literally just they want it as a probability, I should say. They didn't want it as a percent. They want it as a probability to the nearest 10,000th. Again, just make yourself a note. You're talking 4 decimal places. Okay. So then it says Maria took the May version. If Maria scores a 540 on May, okay, so let's talk about this. Obviously above the mean. Let's just say here's your 540. Did she perform as well as Joanne on her exam? Okay, so we have to figure out if she took the May version and got a 540, we're going to figure out at 540 how well she performed on the test. Okay, so I guess we have to figure technically both out. So if I do... Okay, so now let's talk about this. I think this is tough. In part A, we really were finding the percent of the people, the probability of the people that if we pulled at random scored as well as Joanne. We don't know Joanne's percentile rank. Like Joanne's percentile rank is in 3%. Her percentile rank should come out to 97%. In other words, if I did Joanne's percentile rank, so her normal, her mean, standard deviation, and her score. Okay, so let's just talk about this number. If I did that here, I'm going to just clear this out and do her normal, 480. It should be 97%. 24,524. Yes, see, look at that number. 0.9666, creepy, 666, whatever, which is about the 97th percentile. Okay, so why does that make sense? Well, everybody above her was about 3%. You see that in the question above it. So it makes sense that she's at the 97th percentile. Where now let's talk about Maria. Okay, so Maria is the May test, remember. So if I did Maria, we have our normal. Her mean was 510, standard deviation was 20, and she got a 540. So if we do Maria's percentile rank, we have 510, 20, 20, 540. So she's at 0.933, something like that, 19, which is giving Maria a percentile rank of 93, 93rd percentile. Okay, so if they're asking, did she perform as well? No. Maria took the May version. Did she perform as well as Joanne? No. Obviously, Joanne had a better percentile rank. That's what I would say. I would say no. Joanne has a higher percentile rank. Okay. All right, we got one more. Sorry, these things are long. But I just want to make sure you are good and understand that. Okay, so we're at 6. So this last question is talking about annual incomes. They have a mean of 1145, standard deviation of 375. There are 1,200 working students in this town, and Scotty worked last year and had a yearly income of $1,243. Okay, so is it safe to assume that any large sets of data must be normally distributed? No, you can't safely say that. It has to tell you that. So you're going to immediately say, no, not all large sets of data are always normally distributed. You can't just assume that. Not all large sets of data are always normally distributed. Okay, and then the second part says, assume the data is normal. Okay, so now we're assuming it's normal. How many students, okay, not a probability, so we need a number of students, make more money, okay, so now we're talking above, than he does. So remember, if it's more, okay, so I want you to, again, picture your curve. If you are thinking here, your mean was your 1145, and he makes that $1,243 income, you want to know this probability. You want to find that probability and then multiply it by the number of students. So that's the situation where you're going to do 1 minus the normal curve, 1 minus the probability. Get 1 minus, and now let's figure out your mean is 1145. Our standard deviation was 375. And he had a score or an income of 1243. Okay, so we're going to take that probability and then multiply it by the number of working people, which was, I think, 1,200. Okay, so we're going to do 1 minus our normal, because it's everything above it. So it was 1145 was the mean, 375, 1243. Okay, that gives us that probability, which is 0.39691. And we're going to take that and we're going to multiply it by our 1,200 students. So I'm going to call that letter A and multiply it by 1,200. And that's going to give me about 476. 476.301, which is approximately 476 students. Okay, so just be aware whether they're talking about number of students, number of boxes, or they just want your probability. Again, understand those three different situations where if it's anything below that number, okay, if they're talking about your number or your score is below it, you just have to do normal, mean, standard deviation, that number. That gives you anything at or below. If they want it anything above it makes more money. Anything above, you got to do 1 minus that probability. And if it's in between, which we didn't see here, that was from the last lesson, you have to find both and subtract them. Okay, hopefully you're good.